Hi, welcome. Today I'm going to walk you through what for me is the fastest way to get from raw mocap data into Unreal Engine 5 using MetaHumans. We're going to build a pretty simple locomotion system for gameplay. All the cameras are now warmed up and calibrated. Here I am getting suited up. Those green dots are the markers. This is from the camera's perspective. Those blue squares are masked out areas that the camera is not tracking because they're probably other cameras. And here's the 3D view. There you see me and all the cameras. Now we get to the fun part. We're going to do a quick range of motion calibration, which will define the solving skeleton and match my proportions into the digital world. It's important to really stretch out all your joints and rotate everything as much as possible. This sets up constraints based on your range of motion, and this will help prevent any twisting or bone popping issues later when animating. I had to go through this process twice because I wore the wrong gloves. Alright, that was fun. Now, time to start animating. Here I am just going through various locomotions like a forward walk, backward walk. I do like a left and right strafing, some turns, all these animations that you would need for a basic locomotion system. I'm also recording some transitions to make a transition smoother, like from an idle to a walk to idle. For a modern game, you would probably record hundreds, if not thousands, of these animations, but we're going to keep it pretty simple today. I didn't record any running or jumping animations because that would make the tutorial like an hour plus long. Alright, that was fun. Now we take all the animations into Shogun Post, and first thing I do usually is apply autoskeleton to straighten out the feet. You may or may not need to do this based on how your markers are placed, but I run it anyway just because I like my feet to be flat. And then you just verify the data, make sure everything looks good. I had an extra marker on the back of my leg for some reason. And then retargeting. I'm retargeting to the UE5 mannequin. There's a script inside Shogun that makes retargeting to the UE5 mannequin super fast and easy, so I run that. And then retarget over play range, and there we go. It's not perfect, so I have to do some manual adjustments. You can see the arms are kind of weird. And kick. It looks good, but we can do better. So let's improve this animation. First thing we do is go to map mode to manually adjust all the offsets. Next, I'll open up the degrees of freedom on the lower arms on the retargeting skeleton. Unlock rotations on X and Y axis so that it's not locked to Z, and this helps improve the arms right away. Next, I'll straighten out the clavicles because Unreal's clavicle is angled, as you can see here. Just bring them up a little bit and then straighten out the arms to match the solving skeleton a little bit closer. That looks much better. Next, I'll level out the feet a little bit The ankles are usually a bit farther back. I switch back and forth to see and compare to where the solving skeleton is. Straighten out the feet a little bit, make sure they're flat, and then I'll bring the pelvis down just slightly. Then I'll just rotate the wrist a little bit to match the solving skeleton's hands. A lot of this is to taste and trial and error, but I found that this is what works for me. Then update offsets, make sure you exit map mode, and then retarget over play range in that order. And finally, admire your work and move on to cleanup. This is the most time-consuming process for me. It takes the longest, but you really want to make sure that there's no jitter, there's no bone popping, or other anomalies. Then I'll just go through the data frame by frame, using the graph view and just visually inspecting for any markers that are out of place or jittering, and looking for any sharp peaks or dips in the graph. Then I'll either filter it or manually edit the keyframe. Alright, finally, in Unreal Engine, set up a new project, then go to your plugins and turn on everything that says MetaHuman. After it restarts, go to your content folder, right click, go down to MetaHuman, then select MetaHuman Character and name it whatever you want. Select Enable Missing and then restart again. Then you could spend some time customizing your MetaHuman however you want. I kind of just stuck to the presets. I will admit that I spent way too much time messing with his hair and hair color, trying to get it right. In the end, I went with this Dora the Explorer / Willy Wonka style haircut. Looks really cool. I could have easily spent another hour messing with all the little features and hair color, but in the end, we settled on this really nice, really stylish green screen backdrop hair color. I think it looks great on him. Finally, download the textures, create the full rig, assemble it, and save it. Then from the MetaHumans folder, you could drag and drop him into your scene, and he looks great. The hair even matches the background. Awesome. Then double click the MetaHuman blueprint. First thing we do is go to LOD Sync and turn this to 0. This sets it to high resolution always. Compile and save. Next, we need to retarget our animations to fit the MetaHuman skeleton. Ideally, you could import your MetaHuman skeleton into Shogun and then retarget it there. That way you don't have to do it twice, and that prevents a lot of issues. Or you could retarget the animations in Maya, Blender, or Motion Builder, depending on what your pipeline is. Here I select the animation, then select Export Retarget Assets, and open up the IK retargeter, which was auto-generated. Adjust the target mesh offset so that you can see both skeletons side by side. Turn off Debug Draw to remove the green lines. Then select one of the animations that we recorded earlier. You can see the feet are a little slightly angled, so select the foot bone and then adjust it to straighten it out a little bit. This is probably from having to retarget it twice. Then do the same for the other foot, just copy and paste the value so that it's exact. Then do the same process for any other bones that look out of place Just spend some time refining it. Once you're done, hit Edit Retarget Pose to preview the animation again. Now it looks much better. The feet are nice and straight. Everything looks good. Once you're ready, click Export Selected Animations and save it to your animation folder. Now our animation's been retargeted to our MetaHuman. You could go here and select Use Animation Asset and drop your animation on it to preview it. And it looks pretty good. I actually went back and edited the hands a little bit because the fingers were a little odd. Now we're ready to create an animation blueprint. Just right click in your content browser, select Animation Blueprint, then select your MetaHuman base skeleton and create. Once you're inside the animation blueprint, click the asset browser on the right side, and then you can view all the animations that we recorded earlier. Click the Anim Graph tab at the top, and then we could start building our state machines. Right click, type state machine, select it. Once inside the state, we'll drag off of entry and select add state. We'll call it idle. Then select our idle animation from the asset browser and drag it in. Then connect it to the output animation pose. Go back to the state machine. Then compile and save. Now we can see our animation working. Go back to the Locomotion state machine. Drag off of idle, create a new state, call it movement. Then select the transition arrow. We'll go down to variables, create a new variable, call it current velocity, and change it to a vector. From current velocity, we drag off of it and create a vector length node. From return value, we drag off of it, create a greater than node, and then connect the greater than node to the result. Then go back, connect movement to idle, and then select the movement to idle transition, which is the back arrow. Drag and drop the variable, select get variable, drag that off to a vector length node again. From the return value, drag that to an equal, and then connect that to the result. Compile and save. Then go back, select movement, and drop in our walk forward animation. Go back to event graph. From return value, we select is valid, and then connect the execute to event blueprint update. Drag off again from return value to get velocity, drop our get velocity variable. Then we connect from is valid to the set input and compile. If we adjust the current velocity, you can see the character starts moving, but then he stops. Just go back to the movement node and select loop animation. If we adjust current velocity again, we can see that the walking animation is now looping. Perfect. Okay, now back in the MetaHuman blueprint, change the anim class to the animation blueprint that we created earlier. Then under class settings, change the parent class from actor to character. Next, we parent the body to the character mesh and delete the root component. Then drop the mesh that we just created, set it to the target of the get children component. Then lower the body mesh slightly so that it is closer to the end of the capsule. This part will take some trial and error to get right. Around -86 looks pretty good. Then set the rotation on the Z-axis to -90. copy and paste the camera boom and camera from the BP third-person character. Then under the character movement component, we'll copy and paste the character movement settings into our blueprint. Then do the same for character movement walking. And lastly, copy and paste the settings from character movement jumping/falling. Then again, under the BP third-person character blueprint, we'll copy all of this from the event graph and then paste it into our own. Then select create matching function in blueprint for move and aim, then confirm. Then double click this aim node in orbiting camera input. Copy and paste these from the BP third-person character. Then just reconnect these nodes. Next, we do the same for this move node. Highlight all these, Control C, then paste, Control V, and reconnect like so. Then check the Orient to Rotation box. Then uncheck Use Controller Rotation Yaw. Finally hit Compile and Save. Then under World Settings, change from BP third-person character to our MetaHuman blueprint. And it works. Still need some fine-tuning, but our MetaHuman is now functional with our own custom animation. Back in our Locomotion state machine, we'll set the animation to looping. You'll have to spend some time adjusting the max walk speed to match the animation walking speed. This is a little better, but now too slow, so we'll increase it a bit. That's good enough for now. Let's move on to Blendspaces. Right click, go to Animation and select Blendspace, and then select your MetaHuman skeleton. Once inside, we'll change the minimum access value to -180 and the maximum to 180. Then select Snap to Grid. Also check Snap to Grid under vertical axis and then change the name to Speed. Set maximum access to whatever your walking speed is, mine is 125. And then grid divisions to 4. To start, we'll set our idle animation along this bottom line. Then set our forward walking animation at the top here in the center. And now we can blend between the idle and walking animations. Then we'll set our left strafe animation right here and our right strafe animation on the opposite side. And now we can blend between those. Then we'll set our backwards walk animation in these two corners. Back in our state machine, we can delete this and replace it with our blend space. From here, we drag and drop our current velocity, select get current velocity, and then connect it to a vector length node. And then connect the return value to speed on our blend space. Now back in our event graph, we'll connect our get pawn owner to a get rotation, and then connect get velocity to a calculate direction, connect this to rotation, promote to variable, connect these. Now we have a direction variable. We'll drag and drop it here. Now we can transition smoothly between our idle and walking animations. Under the character movement component, turn off orient rotation to movement and turn on use controller desired rotation. And there we go. Now all of our animations are working. And we've just set up a good foundation for a complete locomotion system. This is a great start for building your own custom locomotion system for a game using all animations that I recorded here in my room. I'll include a link to this project file in the description if you want to mess around with it. I apologize if this video went too fast. I had to compress over 3 hours of footage into about 20 minutes, so please forgive me. If you made it this far, thank you so much for watching, and I hope to see you next time. Okay, bye!